Hi, my name is Ashish, and this is the third video in DevOps for Cloud Computing series that we are running these days. Okay, so in this video, we will cover what is version control and what is Git. Well, you may be thinking that there have been only PowerPoint slides in this series so far, but let me tell you this. This is the basics, terminology, and the definitions that we are covering before we start doing the practical stuff with Git, Visual Studio, Team Studio, and Azure DevOps projects thing, and many more orchestration and DevOps products, including Jenkins for continuous integration and continuous deployment. So these are the things, the definitions that you should be aware of. So without wasting any more time, let me tell you the brief about version control and what is Git. Okay, as the slide states, it's the basic overview of version control in Git. To start with, we have definitions. We have version control systems are software that helps you track changes you make in your code over time. As you edit to your code, you tell the version control systems to take a snapshot of your files. Like you have a notepad, you change it, my name is Ashish, then you update this file, then my name is Ashish Arora. I live in New Delhi. So there have been constant changes in the version of the file. So if you have to do it manually, you will have to keep the file save, all three files. A version control system would do it on its own automatically. You don't have to worry about the version controlling of the file. Version control system manages all versions of your code, but presenting you with a single version at a time. It's your wish if you want to roll back to a previous version or some other version that you had saved. Okay, so benefits of version control. See, version control create workflows. Version control workflows prevent the chaos of everyone using their own development process with different and incompatible tools. So if many of your engineers are making a change to the code which is not live, not in production, but yes, they will have to commit their code. So more than 10 or 20 engineers are working on the same workflow or a different workflow within the same code, then it would be a chaos for everyone to track the changes. Version control would do it for you with the proper permissions, and so that every member in the team stays on the same page. It also works with version. Every version has a description for what the changes at the version do. This description helps you follow changes in your code. I'm making a change to an existing code. I'm making a specific change in one of the files. I would make sure that I would highlight it or add a description to my version what I did. Code stored in version control can be viewed and restored from version control at any time is needed. So there are many good benefits of version control. Code together. Version control synchronizes versions and makes sure that your changes don't conflict with other changes from your team. Your team relies on version control to help resolve and prevent conflicts. Even when people make changes at the same time, it depends. It's the duty of the version control system, no matter how many changes are being made to the code, what all members are doing, it would keep the code consistent. It also keeps a history. Version control keeps a history of changes as your team saves new versions of your code. This history can be reviewed to find out who, why, and when changes were made. So this is a kind of logging that is always on to track the changes in the code history that were made, so that you can be aware of who, why, and when made those changes. It automates tasks. Version control automation features save your team time and generate consistent results. Automate testing, code analysis, and deployment when new versions are saved to the version control. Okay, that was version control. And how do you do version control? Git is an open source repository. It is the most commonly used version control system today and is quickly becoming the standard for version control. Well, this Git is a distributed version control system, meaning your local copy of the code is a complete version control repository. So you make changes offline, and when you want to commit the change to the server, deployment, or the test branch, I will let you know what the branch is. You can do it. You commit your work locally and then sync your copy of the repository with the copy on the server. So you are making changes into your code offline, and you can easily connect with the server while deploying a newer version of your code to your repository, to your Git repository. Basics: every time you save your work, Git creates a commit. A commit is a snapshot of all your files at a point in time. So commit creates links to other commits, forming a graph for your development history. You can divert your code to a previous commit, inspect how files change from one commit to the next, and review information such as where and when changes were made. Commits are identified in Git by unique cryptographic hash of the contents of the commit. So don't worry if you're not getting this basic terminology definitions as of now. I will show you the lab, how I make the repository, how I make the changes in the Visual Studio, what role did Git version plays. So as I told you, we have branches in the repository. Each developer saves changes their own local code repository. As a result, you have many different changes based on the same commit. Git provides tools for isolating changes and later merging them back together. Branches, which are lightweight pointers to work in progress, manage their separation. So there is a master branch that you're working on, okay, and you can easily make changes, and you can add some feature, you can commit later onto your master branch. Files and commits. Files in Git are in one of the three states: modified, stage, or committed. It doesn't mean you make a commit your code into the file, it will be automatically be in the final stage. No, when you first modify a file, the changes exist only in your working directory. They are not yet part of a commit of your deployment history. We have to stage the changed files that I want to include in my commit code. The staging area contains all changes that I'll include in the next commit. Once I'm happy with the stage files commit with a message describing that what change, I have to specify what changes am I committing to the production code. This commit becomes part of the development history. This was all that I have to cover in this video. I hope this was informative to you. I will share more on this and keep coming with the more labs so that you will get more information about DevOps. So this is will be a very descriptive series, and I hope you will enjoy it. Please don't forget to subscribe to this channel and like it. Till next video, have a great day ahead.